All right, finding conditional probability with two-way tables. The ACT loves these questions, and so does the end-of-level test that you're going to take at the end of the year. They love giving you these tables and seeing if you can take the information from them and apply it to a problem. So it gives me this table. A satellite TV provider surveys customers in 3 different cities. It looks like Glendale, Santa Monica, and Long Beach. And asks them if they would recommend the TV provider to a friend. So this two-way table actually has 3 columns and 2 rows, right? You're comparing 3 cities and if the people in those cities would recommend their provider or not recommend their provider. And it doesn't give me the numbers. It doesn't give me like 300 people in Glendale and 250 people in Santa Monica. It gives me the frequencies. So it's giving me the percentage. So it's saying 29% of all the people, not just, remember, this is 29% of everyone lives in Glendale and says, yes, they would recommend. 5% live in Glendale and say they would not. 3% live in Santa Monica and say they would not. 32% live in Long Beach and say they would. All right, so that's how we read the table. What it wants me to find is what is the probability that a randomly selected customer who is located in Glendale will recommend the provider. So it wants to know if someone lives in Glendale, what's the probability that they recommend the provider? So this is one of those conditional probabilities that looks like this. What's the probability that someone will recommend given that they live in Glendale? So it's not asking out of all of the people. It's just asking of the people that live in Glendale, what's the probability that they are going to say yes? So the percentage of people that live in Glendale, we probably need to add a little bit more to this chart because I know that 29% in Glendale said yes and 5% said no. So that means total there's 34 or 0.34% of people in Glendale. There's 0.30 people, 30% of the people from Santa Monica, and that leaves 36% of people in Long Beach. So when I'm calculating this, when I'm finding the probability, on the bottom is going to be all of the Glendale people. I don't care about Santa Monica. I don't care about Long Beach because it only wants people that are located in Glendale. And that is 34%, 0.34. That's how many of the total people live in Glendale. And how many of those recommend is this number right here, 0.29% of the people. So in my calculator, I'm going to put 0.29 divided by 0.34. So let's do 0.29 divided by 0.34. When I hit enter, I get 0.8529. So let's round that to be 0.853. 0.853 is the probability. So I have an 85. So that would translate to what? 85.3% chance that if a person lives in Glendale, they do recommend their TV provider. Okay? What's the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So this one's a little bit backwards. What's the probability that if we're talking about not recommending the provider, so not recommending is going to actually be the second part here. What's the probability that if they don't recommend the provider, they are located in Long Beach? So we're not interested in all of the people. We're only interested in the people that don't recommend their provider. So that means I need to find another total. This group, and this group all don't recommend. So if I add those together, I get 0.12. Whoops, not 0.121. I get what, 12%, right? 0.05, 0.03, 0.04. That's about 12%. all of the people that do recommend would add up, hopefully, to 0.88 if I added that top 3 together. So if I want to know the probability of if someone doesn't recommend the provider that they are from Long Beach, on the bottom is the total that don't recommend, 0.12. On the top is the percentage that are from Long Beach out of that group, right? So we're looking at, we added those up, right? 0.12 is okay. So we're looking for the group that is from Long Beach and didn't respond, which is this 0.04, is what's going to go on top because they did both. And the 0.112 is my total. So when I divide that, 0.04 divided by 0.12, 0.04 divided by 0.12, I'm going to get 0.33333333, which hopefully you know is a third, or 0.33 or 33.3% of people who don't recommend come from Long Beach, is what that means. 33% or 1 out of 3 people who don't recommend happen to be located in Long Beach. Okay, let's do, we got time. Determine whether recommending the provider to a friend and living in Long Beach is independent. Ooh, this is a good question. What's the probability that recommending and living in Long Beach are independent? Well, the probability of recommending and living in Long Beach, if it was independent, that would equal the probability of recommending multiplied by the probability of living in Long Beach. So let's find those 3 things. Probability of recommending. If I go up here, I'm going to erase some of this stuff. All right, what's the probability that someone recommends? Well, we already found that. This group recommends, so that would be 0.88. So the probability that someone recommends is 0.88. And I'm going to multiply that by the probability that someone lives in Long Beach. Well, these people and these people live in Long Beach, so 0.36 is the probability that someone lives in Long Beach. So 0.88 times 0.36, let's see what that is. 0.88 times 0.36, that's going to give me 0.3168, so 0.317, approximately 0.317. All right, now let's look at the probability that someone recommends and lives in Long Beach, okay? So the probability that someone recommends and lives in Long Beach is this group right here, which is 0.32. So this would be 0.32. And here's where you would have to make an opinion. 0.32 is really, really close to 0.317. So in my opinion, I would say yes, these are independent. It doesn't matter where someone lives. That's not going to affect if they do or do not recommend their TV provider. One of those does not affect the other. Because those numbers are really, really close, they're basically the same thing. All right, okay, let's do a couple. You might be ready to start the video. Where is my questions? I don't have my questions written down. Oh, we'll get there. Okay, let's do number 5. We won't do number 6, but we'll do number 5 here. In example 4, what's the probability that randomly selecting a customer who is located in Santa Monica? So what's the probability if someone is located in Santa Monica that they will not recommend the provider? So Santa Monica not recommending. So when I go up to my table, what percentage are in Santa Monica? That's this right here, 0.30. So I have I'm looking at 0.30 of all the people. I'm not looking at everyone. I'm just looking at 0.30 of them. And it wants to know how many of them do not recommend. So out of that group, 0.03 do not recommend their provider. So 0.03, I would divide these, 0.03 divided by 0.3, 0.03 divided by 0.3, and we should get 10%, which is 0.10. So that would be 1 out of 10, or 0.10, or 10%. So 10% of people who live in Santa Monica don't recommend their provider, all right? Okay, last example. A jogger wants to burn a certain number of calories during his workout. He maps out 3 possible routes. Before each workout, he randomly selects a route and then determines the number of calories he burns. Which route should he use? Is that the example that we want to do? Or do we want to do this one? Let's do this one. A manager is assessing 3 employees in order to offer one of them a promotion. Over a period of time, the manager records whether the employees meet or exceed expectations on their tasks. The table shows the manager's results. Which employee should be offered the promotion? All right, so let's look at, we've got 3 different employees. We've got Joy, Elena, and Sam, or Elena, Elena probably, right? Joy, Elena, and Sam. And then the manager is recording whether they meet expectations or exceed expectations on their tasks. And it wants to know which should be offered the promotion. So first of all, let's look at Joy. Joy, if we finish filling out this table, which I feel like we should probably do, don't you think? Let's finish filling this table out. Joy it recorded her 15 times. It recorded Elena, let's see, 10, 11, 12, 17. She got recorded 20 times. Sam has 11, 12, 13, 18 records. So total, that's what, 43 times that somebody was, let's see, 23, 33, 53. So that's 53 records that were taken. Of those records, 9 from Joy exceeded expectation, 12 from Elena, so that's 21, and Sam had 11, so that's 32. Meeting expectations, we had 6, and then we had 8, which is 14, and then we had 7 more, which is 21, and that adds up to 53 as well. All right, so it wants us to decide which employee should get the promotion. All right, and looking at this table, Elena has the most exceeding expectations, but she also had the most total reviews, right? Joy had less exceeding, but she also had less total. So instead of looking at just the raw numbers, let's look at the percentages out of the total, all right? So Joy, if I look at her percentage, we're going to make the relative frequencies of all of these numbers, all right? So we're going to do 9 divided by 53, and that's going to be Joy's value there. So we're going to do 9 divided by 53, and that's going to give me 0.169, so let's do 0.17. So approximately 0.17. Meeting expectations is 6 out of 53. So 6 divided by 53, which is 0.113. So this is about 0.113. Elena, so this is Elena, this is Sam, this is Joy. Elena has 12 out of 53 and 8 out of 53. So 12 out of 53 is 0.226. So approximately 0.226 are from Elena, and 8 out of 53 gives me 0.151. So approximately 0.151. Sam, I've got 11 out of 53, and I've got 7 out of 53. All right, 11 out of 53 is 0.208. Whoops, not that one. 0.208. 7 out of 53. I don't think we've done that one yet, right? 7 out of 53 is 0.132. So 0.132. Now, if I just look at these numbers, 17% of the responses, Joy exceeded expectation. Elena exceeded expectation 22%, but it's not comparing. We have to be careful because this is comparing their numbers to the total of 53, which is one thing to look at, right? That number might mean something to you. But I would be more interested in, out of all of Elena's reviews, what is her percentage of exceeding expectation as opposed to just meeting expectation? I don't care what her percentage is out of everyone. I want to know what's her percentage just based on her own individual ratings. So I'm interested in these numbers as well, the totals. So Joy, 0.17 plus 0.1173 is 0.283. Whoops, 0.283. Elena, 0.226 plus 0.151 is going to be what? 0.377. So see, Elena has 37% of the reviews. Joy only has 28%. Sam has 0.208 plus 0.132, so that's going to be 0.340. And Sam has 34% of the reviews. So what I want to know is the conditional. Out of Joy's reviews, how many of them were exceeding expectation? Out of Elena's reviews, how many of hers were exceeding expectation? So what I want to actually calculate is 0.17 out of 0.283, not the total. And for Elena, I want to do 0.226 out of 0.377. And for Sam, I want to do 0.208 out of 0.340. I want to know, out of their reviews, how many of them exceeded. So let's do 0.17 over 0.283. Calculator, 0.17 divided by 0.283. So 60.6007. So about 0.601. 60% of Joy's reviews, she was exceeding expectations. So now let's check Elena. 226 over 377. 0.226 divided 0.377. 59.599 is going to be approximately 0.600. So just barely underneath is Elena with just a little bit less exceeding expectation. Such a small amount, actually, that it probably doesn't matter. Hopefully, Sam's is significantly different so that it helps us make a decision. 0.208 over 0.340. So 0.208 divided by 0.3, 40. 61.2%. Approximately 0.62 or 612. My bad. 612. So Joy exceeded expectation 60.1%. Elena exceeded expectation 60%. Sam exceeded expectation 61.2% of the time. That's a really hard decision to try to choose who had the best percentage because they're all really, really close. If this is all that you were basing it on, then Sam is the one that has the better record of reviews. So, all right. Homework, 5.3. Homework. What I would like you to do to finish off is 13 and 14. And then I want you to do 17 and 20. Okay, 13, 14, 17, 20. This is a short homework, which kind of balances out with the longer videos.